Hello everyone. Today's lecture is extremely important, that is side distance consideration. One question will 110% come from this topic. If I talk about GATE engineering services, every year question from this topic come. If I talk about 2019 RNB Road and Building Department exam as well as 2019 GES Gujarat Engineering Services, one question have came from this topic. In this video, we'll see fundamentally what is side distance consideration, types of side distance, detailed discussion on stopping side distance, and question practice on SSD, that is stopping side distance. So, dear students, stay tuned till the end. રોડ પર સેફ એન્ડ એફિશિયન્ટ ઓપરેશન જોઈતું હોય તો એ ડિપેન્ડ કરે છે કે ડ્રાઈવરના આગળ રોડ પર વિઝિબિલિટી કેવી છે. ડ્રાઈવરના આગળ રોડ પર વિઝિબિલિટી કેવી છે. ધ સેફ એન્ડ એફિશિયન્ટ ઓપરેશન ઓફ vehicle on the road depends very much on the visibility of the road ahead to the driver. એટલે જોમેટ્રિક ડિઝાઇન રોડની એ રીતે કરવાની કે રોડના લેન્થ પર કોઈ ઓબ્સ્ટ્રક્શન હોય એ ડ્રાઈવરને ઇઝીલી દેખાઈ જાય થોડા ડિસ્ટન્સ પહેલાં જ, અને જે ડિસ્ટન્સ જ્યાંથી ડ્રાઈવરને ઓબ્સ્ટ્રક્શન વિઝિબલ થાય છે એ ડિસ્ટન્સને આપણે કહીએ છીએ સાઇડ ડિસ્ટન્સ. Thus the geometric design of the road should be done such that any obstruction on the road could be visible to the driver from some distance ahead, and this distance is known as nothing but sight distance. Now we'll see what are the types of sight distance. Sight distance available from the road is the actual distance along the road surface. Sight distance જે available હોય છે એ actual distance છે along the road surface over the drivers from a specific height above the carriageway which has to be visible. જે visible object હોય છે એ object stationary બી હોઈ શકે અથવા હોઈ શકે moving object. It may be the stationary object, may be moving object. So sight distance available from the point is the actual distance along the road surface over which a driver from a specific height above the carriageway has a visibility of what object? Stationary or moving object. Three sight distance are to be considered while designing. First is stopping sight distance or absolute minimum sight distance. Second is intermediate sight distance, which is defined as twice of SSD. This also some of the time question comes in the exam. ISD is how many times of SSD? ISD is nothing but ISD is equals to 2 times of SSD. Please remember this. ISD is equals to 2 SSD. Third is overtaking sight distance, OSD, for safe overtaking operation, right? Fourth is even your headlight sight distance is the distance visible to the driver during the night driving under the illumination of the headlight, right? And fifth is your safe sight distance to enter into an intersection. Now, the most important consideration in all this is that all the time driver traveling at the design speed of the highway must have sufficient carriageway distance within his line of vision to allow him to stop his vehicle before colliding with a slowly moving or stationary object appearing suddenly in his traffic lane. Stopping sight distance, SSD. We'll see the definition. It is the length of the road. It is the length of the road visible ahead. It is the length of the road visible ahead to the driver's eye. To the driver's eye. To the driver's eye from a specific height. From a specific height above the carriageway, from the specific height above the carriageway at any instant of time, to stop the vehicle safely to stop the vehicle safely before collision. To stop the vehicle safely before collision or without collision. A length of the road visible છે ahead to the driver from a specific height above the carriageway કોઈ બી ઇન્સ્ટન્ટ પર so that driver can stop his vehicle safely without collision. અને એ જે ડિસ્ટન્સ છે એ ડિસ્ટન્સને આપણે કહીએ છીએ સ્ટોપિંગ સાઇડ ડિસ્ટન્સ, એને બીજું આપણે કહી શકાય એબ્સોલ્યુટ મિનિમમ સાઇડ ડિસ્ટન્સ ઓર નોન પાસિંગ સાઇડ ડિસ્ટન્સ. This term is also called as safe stopping distance, and it is very important in the design measure in traffic engineering. अलग रीते જોઈએ, it is the distance a vehicle travel. જો ધ્યાનથી, it is the distance a vehicle travel from a point at which a situation is first perceived to the time deceleration is completed. To the time deceleration is completed. It means that it is a distance, એક એવું ડિસ્ટન્સ છે જે વેહિકલ ટ્રાવેલ કરે છે ક્યાંથી, જ્યાંથી એ ઓબ્જેક્ટને અથવા ઓબ્સ્ટ્રક્શનને જોઈ છે, જ્યાં સુધી the vehicle is completing his deceleration. It means that the vehicle is stopping. To understand this, let's say this is the road you have and I'm showing one vehicle. Jodhyanti, I'm showing one vehicle. This vehicle is moving with the velocity. Let's say this is the vehicle you have and this vehicle is moving with the velocity. I'm showing the vehicle. This vehicle is moving on the road with, let's say, v meter per second. This vehicle is moving on this road. I'm showing here this vehicle is moving with the velocity small v meter per second. Wherever in this throughout this session series, wherever I write small v, it is meter per second, and wherever I'll write capital V, it is kmph, kilometer per hour. If they give you kmph, you want to convert into meter per second, just divide by 3.6. Small v equal to capital V divided by 3.6. Now this vehicle which is traveling with some velocity v meter per second sees some object or obstruction. If I talk about whatever the specific height above the carriageway, it is the height of a driver's eye above the carriageway, which is 1.2 meter according to IRC, please remember, and object height is 0.15 meter. Now this vehicle has seen the object or obstruction and the vehicle will not suddenly apply the brake. He will, or the driver will, perceive the object or obstruction. It will travel some distance after perceiving the object, and at this point which I am showing, at this point the drivers apply the brake. As soon as he apply the brake, what will start? Whatever here the velocity will be meter per second. From this point velocity starts to deaccelerate. It means that velocity starts to decrease from this point of time. At this point deacceleration start. Now the vehicle travel after applying, and at some point of time the vehicle stops safely without collision at this point, and at this point velocity of the vehicle will be equal to what? The velocity of the vehicle have stopped, so the velocity of the vehicle is equals to nothing but what? 0 meter per second. Now the total distance which I am showing you, the whatever the stop vehicle here, and the total safely the vehicle stops here. Now I am showing you the total distance starting from where the vehicle stops. That distance is nothing but SSD, stopping side distance. It is the distance a vehicle travels from point at which situation is first perceived to the time deacceleration is complete. The point from which he perceived the object and he applies the brake, that distance he travel is known as lag distance. We'll see detail what is lag distance. And after applying the brake, whatever distance the vehicle travel and stops, that distance is nothing but braking distance. It means that you can say that stopping sight distance is the sum of leg distance, plus and braking distance. Therefore, SSD is equals to leg distance and braking distance sum. Leg distance. Leg distance is the distance which a vehicle travel after perceiving the object until the time apply the brake, which is equals to V into T, where T equal to total reaction time. T is equal to total reaction time. Reaction time of the driver is the time taken from the instant the object is visible to the driver to the instant when the brake are applied. It means the total reaction time is the time required when initially the driver sees the object till the time drivers apply the brake. That duration is nothing but total reaction time. Please see the duration, I am showing you T, the total duration, that this duration is nothing but total reaction time. The total reaction time, this total reaction time may be split into four components based on PIEV theory. PIV theory I have shown here in the diagram. Please see, split up into four components based on the PIV theory. PIV theory I have shown here. Here I have shown the diagram of a spinal cord. I have showed a spinal cord in the diagram. This is known as spinal cord, also known as nervous system. And the upside I have showed the brain, right? The human brain, whatever the signal or the perception, anything is traveled from the spinal cord nervous system to the brain. First time is known as perception time. Is a time required for the sensation received by the eyes or ears of the driver to the transmitted to the brain. When the drivers perceive the object, the time lost in perceiving the object is known as perception time. Second time is known as what? Intellection time. The time required for the driver to understand the situation. Time lost in understanding the situation is known as intellection time. Therefore, I for intellection. Third is emotion. When the object the driver sees or obstruction, there may be emotion, that is nothing but fear, anger. That time lost in the emotion is known as emotion time. And final is time lost in taking the final action. Some of the time suddenly the brake is applied without any perception, intellection, emotion is known as what? Reflex action, which I have shown here. So according to IRC, the whatever this time, this total reaction time is taken to be 2.5 second. Please remember, some of the time they can ask this 2.5 second. This 2.5 second, why they were taken 2.5 second is this time is known as 90th percentile time. This time is known as 90th percentile time. It means that total of the road user, out of which 90% of the road user will apply the brake with or less than 2.5 seconds. If you see carefully, study shows that the time required is nearly about 1.5 to 2 seconds under the normal condition. But because of variability of the driver user you see on the road, therefore IRC have taken 2.5 seconds only. And they have considered only 90th percentile. It means that the remaining 10% of the people IRC is not considering. This 10% of the people are people like having the inebriated state, having drink and drive, having alcohol, or second is the unsound people, because that people will take lots of time in applying the brake. That condition the IRC have not considered. It means that condition of the driver's mind is not considered in the total reaction time. This also question have came in IAS prelims earlier in 2007. So condition of the driver's mind is also not considered in calculating the reaction time. Braking distance. Braking distance is the distance traveled by. Braking distance is the distance traveled by the vehicle. Distance traveled by the vehicle during. Distance traveled by vehicle during braking operation. Whatever amount of the distance traveled by the vehicle during the braking operation, that distance is nothing but what? Braking distance. It means that after applying the brake till the vehicle stops stop, that whatever distance I have shown here, that distance is nothing but what? Braking distance. The vehicle stop, the reason is just because the work is done by the friction to stop that vehicle. Here I have shown D1, that distance is nothing but lag distance, and D2 is nothing but what? Braking distance. Lag distance we have calculated V into T. This can also be calculated, braking distance, by equating what? Equating work done in stopping the vehicle, and who is doing the work? Friction is doing the work to stop the vehicle. This is obtained by equating the work done in stopping the vehicle and the kinetic energy of the vehicle. It means that you will use the work energy theorem to calculate the braking distance. That is, we'll use change in kinetic energy is equals to work done by the friction to calculate the distance d2. That distance is nothing but what? Braking distance. Now we'll see the derivation part, that what is the braking distance. Now after stopping the vehicle, the velocity of the vehicle becomes 0 meter per second. Okay, we'll see. While what will apply? We'll apply the energy theorem. That is, applying the energy theorem to calculate the braking distance. So I've showed here work is done by the friction in the opposite direction of the movement of the traffic. That is, work done by the frictional force is equals to coefficient of friction into normal force. Downward force is the weight, and upward force the normal force, and normal force is equals to the weight, right? So F into N, or you can write F into W, because N is equals to W. So change in kinetic energy, is equals to work done by the friction, is equals to work done by the friction. Therefore change in kinetic energy, if I write down, that is 1 by 2. Here I'm assuming the braking efficiency, which is equals to 100%. This B is equals to 1. Therefore you can write as what? Change in kinetic energy, write as what? Whatever the initial part is half of mv1 square. Initial, where the brake applies, it's section 1 right? Where the vehicle applies the brake, section 1 I'm showing, and the section 2 where the vehicle stops safely without collision. Half mv1 square minus half mv2 square is equals to work done by the friction. Work done equals to force into displacement, right? Force into displacement. So half m, whatever this v1 is nothing but v, and v2 is equals to what? 0. Therefore half mv square is equals to work done is nothing, force is equals to frictional force F into N, and displacement is nothing but what? D2, which we want to calculate. There is nothing but what? Braking distance. D2 is equals to braking distance. That you can write as what? Half of m v square is equals to F into W into D2, and W you can write as nothing but m into G. So F into m into G into what? D2. M and m cancel. Therefore D2 is equals to V square divided by 2GF. Therefore braking distance we have calculated, D2 is equals to V square upon 2GF. Why I have shown this derivation is, some of the time instead of V2 equal to 0, they can give some other value of velocity also. Some of the time there is a restriction to enter into the ramp. That time of time derivation is important. Therefore SSD you can write as what? Lag distance V into T plus of what? Braking distance V square divided by 2GF. Therefore SSD you can write as what? V into T plus V square upon 2GF. If braking efficiency is given, if they give you braking efficiency 70%, 50%, 80%, then B is given, then SSD become equals to V into T plus V square upon 2G F into B. There is always combination of frictional resistance F into what? B. Now whatever this F value is nothing but what? Longitudinal friction, coefficient of friction. This longitudinal coefficient of the friction, according to IRC, have certain particular value. That value is nothing but 0.35 to 0.4 according to Indian Road Congress. Effect of gradient on braking distance. First we'll see, that is nothing but your ascending gradient. If I talk about ascending gradient, in the ascending gradient I call it as positive. You'll come to know why I will call it as positive. I have shown one gradient here which is at some angle theta, if you see carefully, and the vehicle is going on over this gradient, this ascending gradient. there is no change in the leg distance. Leg distance remain the same whether it is on a plain road or a gradient, that is V into T. In the gradient effect of the gradient, only braking distance get changed because of the gradient. So you should know that leg distance remain the same, only there is change in the braking distance. So this vehicle applies the brake after looking at the obstruction on a gradient, and this vehicle stops safely after applying the brake without any collision. That is, this is the vehicle you have, this stops safely. So this, whatever the initial I call it as section 1.1, this is the section 1.1, and this at where it stops is nothing but section 2.2. There is nothing but this is the section 2.2. Now if you see carefully that the whatever the gradient I've shown with an angle theta, so in the downward direction the weight is applied, in the vertical downward direction the weight of the vehicle, that is W. Now the component of this weight will be, first if you take this angle as theta, this will be a theta angle, so this is W cos theta component, and it will be, you got W sin theta component. W sin theta component is helping to stop the vehicle weight sin theta component. Now this distance is nothing but d2, that distance we need to calculate, that is nothing but what, braking distance. This is nothing but what, braking distance. So this initially velocity is v, and after stopping velocity of the vehicle become v equal to 0. Now if you see carefully, upward force will be the normal force, and this normal force equals to W cos theta component. So if you see the frictional force is equals to coefficient of the friction into normal force, and the normal force is nothing but W cos theta, right? So F into this coefficient of friction, that is F into W cos theta. Now applying which theorem? Applying the theorem that is nothing but the energy theorem. Applying the energy theorem, that is change in kinetic energy is equals to work done, right? So applying the energy theorem, so we see that half of m v1 square minus of half of m v2 square is equals to, who is stop, work is done by the frictional force as well as W sin theta component, the Wf into W cos theta plus of what, W sin theta, that is the force into displacement is d2, we need to calculate. So this v2 equal to 0, v1 is equals to v, therefore half of m v square is equals to, if I'll take common W cos theta common, if I'll take, so I can add as nothing but what, F plus of what, sin theta upon cos theta is equals to tan theta into what, d2. So I can add as what, half of m v square, and W is equals to m into g cos theta, F plus of what, tan theta into what, d2. M and m will get cancelled, therefore I can add as what, half of m v square divided by or equal to g cos theta into in bracket F plus of what, tan theta into d2. So when theta is very small, right, when theta is very small, cos theta is nearly equals to 1, therefore you can write as what, cos theta nearly equals to 1, therefore you can write d2 is equals to, I can write as what, d2 is equals to v square upon 2g in bracket F plus of what, tan theta. So this is nothing but what, this is your braking distance with consideration effect of gradient. d2 is equals to v square divided by 2g F plus of what, tan theta. You can write as what, tan theta, or you can write as what, x%, or you can write as what, 1 by n, all are same. So tan theta is equals to see this tan theta x% I have shown in the camper, so please watch the video lecture 1 of this series. So SSD is equals to leg distance v into t plus of what, v square divided by 2g F plus of what, tan theta. Now if the braking efficiency is also given, now minus sign I have showed here, that is plus sign for the ascending gradient, minus sign for the negative, this is descending gradient. So negative will come for the descending gradient. So if some of the time the descending gradient is given to you, at that point of time you need to use negative sign instead of positive sign. So earlier I showed you ascending gradient positive, descending gradient nothing but what, negative, right? So now some of the time they give you the braking efficiency is given to you, that is b value is given to you. We know that F is multiplied by b, then SSD is given as SSD is equals to v into t plus v square divided by 2g F into b plus of tan theta. So this is nothing but what SSD if braking efficiency is given and effect of gradient is considered. Computation of side distance depends upon various factors. To understand this, we'll write down the equation of SSD. SSD is equals to leg distance v into t plus v square divided by 2gf plus or minus of what? Tan theta. So we'll see what factors or computation of the side distance depends upon what factor. First factor is nothing but what? Reaction time of the driver. We have seen t, which is equals to 2.5 seconds. So it means that side distance first depend upon the reaction time of the driver, the small t. Second is speed of the vehicle. The second is nothing but what? Speed of the vehicle v. The speed of the vehicle very much affects the side distance. Higher the speed, more will be the required time to stop the vehicle. Hence, it is evident that as the speed increases, side distance also increases. Second factor. First is small t and second is nothing but what? Speed of the vehicle. Third is nothing but your efficiency of the brake. Third is nothing but what? Efficiency of the brake. The efficiency of the brake depends upon the age of the vehicle, vehicle characteristics, etc. If the braking efficiency is 100%, then the vehicle will stop at the moment the brake applied. But practically, it is not possible to achieve 100% braking efficiency. Therefore, side distance required will be more when the efficiency of the brake is less. It means that efficiency is less, side distance will be more. It means that for the safer design, IRC have taken only 50% of the braking efficiency. So it have only considered 50% efficiency. It means that if we have the 50% of the braking efficiency is the worst condition, condition the driver is safe, then in the safer condition driver is already more safe. Fourth is nothing but what? Frictional resistance between tire and the road. The frictional resistance between tire and road plays an important role in bring the vehicle to stop. When the frictional resistance is more, vehicle will stop immediately. Thus, the side required will be less. No separate provision for the braking efficiency is provided while comparing the distance. So, if we talk about the see the F into B is there, so braking efficiency is more than the SSD, the side distance required will be less. So F into B is equals to constant. Actually, the value of F is not taken idle, it is multiplied the braking efficiency. So whatever the value I've written here 0.35, or I've showed you earlier also 0.35 to 0.4, that is actually F into B value. So F actual value is nothing but what? Into 0.5 equal to 0.35. Therefore F is equals to 0.7. So actually we are underestimating the value of actual value is 0.7, but we are taking what? The worst condition, that is nothing but what? Braking efficiency 50%, F value is 0.7. Here I have showed you the value of F for calculating the SSD, different value of F for the speed. So please remember this particular value also. So fifth is nothing but what? Gradient of the road. Gradient of the road also affects the side distance. While climbing up the gradient, the vehicle can stop immediately. Therefore, side distance required is less for the ascending gradient. While for the descending gradient, gravity also comes into action and more time will be required to stop the vehicle. Therefore, the side distance required will be more. It means that ascending gradient side distance will be less, whereas in the descending gradient side distance will be more. So this is nothing but what? Gradient, right? Gradient. Please remember this traffic type. First is if you have single lane one way, which I have shown in the figure, that you need to take only SSD. If you have single lane and two way, you need to have 2 times of SSD. So please read carefully in the question what they have given. Single lane, and if you're 2 lane two way, then you only need to consider SSD. So you have to take care all of these 3 cases, and please SSD, 2 SSD and SSD. Now we'll see the question which I'm asking in Gujarat Engineering Services Main 2018. Calculate the stopping side distance for the design speed of 50 kmph for first given. They have given the value of the speed of the vehicle design speed, which is nothing but what? 50 kmph, and you need to calculate the SSD. First condition is your two-way traffic on a single road, that is value of V can be calculated as what? V divided by 3.6 in meter per second, that 50 divided by 3.6, which is 13.88 meter per second. So first A will calculate two-way traffic on the road. F value is given as 0.37 and the reaction time is given as 2.5 seconds, right? So first we need to calculate two-way traffic on the single lane road, that is you need to calculate SSD, right? V into T plus V square by 2 GF, therefore V into T, so 13.88 into 2.5 plus 13.88 square divided by 2, G value is 9.81 into F value is 0.37. So 13.88 into 2.5 value, if you calculate it, values will be see 13.88 into 2.5, 34.7 plus this value will be 13.88 squared by 2 into 9.81 into 0.3 divided by 0.3, and this value will be 26.538. So if you add it, 34.7 plus 26.538, this value is 61.238 meter. So first is this. Now B is two-way traffic on a single lane road, single lane two-way traffic. So we need to have what? Multiply by 2 times of SSD. So two-way traffic on a single lane road, we need to multiply this value by 2, therefore which is equals to 2 into SSD, which is equals to 2 into 61.238, which is equals to, please see the value, which is equals to 2 into 61.238, 95.938 meter. So this question was there of 5 marks in Gujarat Engineering Services. Very simple question in GES mains. So this was 5 marks question asked in the GES mains. Simple question. This type of question, even you'll be observe this type of question, simple question, but just you need to have concepts of this SSD. Second question is calculate the following, consider the following factor which was asked in GES 2017 prelims. They have given 4 factors. First is reaction time, second is speed, third is coefficient longitudinal friction, and fourth is gradient. So we can write as what? D2 equal to V square divided by 2 GF plus or minus of what? Tan theta. Which of these factors are taken into account for computing braking distance, right? Braking distance. So reaction time is not considered. Second is speed. Yes, speed is considered. So first A and B option is eliminated. Third is coefficient longitudinal friction. Yes, and gradient is also considered. So option C will be there. Second, third, and fourth. Simple question asked in GES Gujarat Engineering Services 2017 prelims. So option C is the correct option. Now we'll see the question 3. In the calculation of SSD, the height of the driver's eye, level of the driver's eye, and the height of the object, we know it. This was asked in Gujarat Maritime Board, 1.2 meter and 0.15 meter. Question 4. As per the IIC coefficient longitudinal friction for the calculated SSD, we have seen this. So we can see the speed on corresponding to this 0.36. So 60 to 65 kmph, 0.36. Question 5th is stopping side distance is increased with. We need to increase the stopping side distance. So increase in the braking efficiency. So we'll see the write down the equation. SSD equals to V into T plus V square by 2 GF plus or minus tan theta. With increase in braking efficiency, if I write down braking efficiency B with F. So if I write down B with F into B, I can write if this increases, then the braking SSD decreases. So first option eliminated. So this braking efficiency decreases, then SSD ultimately nothing but what? Increases. So option B will be the correct answer. Increase in the frictional resistance will decrease. So option C is not will be there. Decrease in the braking reaction time. So option B is the correct answer for this. Such type of simple questions are coming because we have framed our concept very well onto SSD. You can note down in your notes also. Thank you so much, dear students. Don't forget to subscribe us on the YouTube channel and even follow us on Instagram, Akshay Sir Holistic. And if you have any query, you can contact us on the WhatsApp.